All right, you guys. So we are actually going to just skip past one page in your notes and we are going to jump to the second page of your notes about quadrilaterals. So go ahead and if you need to pause the video so you can get opened up to this page. But I want to specifically, now that we just finished the video about classifying quadrilaterals, I want to focus in on talking about those different properties of a quadrilateral. So our directions here are telling us to place a check mark on the properties that apply to each quadrilateral. So like I fully anticipate that you are going to do a lot of flipping back and forth to the page that we just did with the flow chart of the different types of quadrilaterals, and feel free to if you need to. All right, I am going to go ahead and get started up at the top with a parallelogram. So a parallelogram, I am going to draw a picture off to the side. Whoops, that was a bad parallelogram. Let's redo that again. Okay, so a parallelogram is going to have like these really angled pieces. It's going to have this pair of parallel sides, and it's also a parallelogram has to have two pairs of parallel sides. So right here it says exactly one pair of opposite sides parallel. That does not work for a parallelogram because a parallelogram has both sides that are parallel to each other. And so with these first two categories, it's kind of like a one or the other type of scenario. It can either have exactly one pair of opposite sides that are parallel or both pairs. It cannot be, you can't have check marks in both of those columns, right? So the next column here is opposite sides are congruent or four sides are congruent. And so for this one here, my opposite sides of a parallelogram are always going to be congruent, but it does not necessarily for a parallelogram, all four sides do not have to be congruent. And then where it says four right angles, a parallelogram does not necessarily have right angles. There are specific types of parallelograms that do, but the general blanket term for a parallelogram does not have four right angles. All right, so next up, we're going to take a look at a rhombus. And so a rhombus is super duper similar to a parallelogram, right? A rhombus is going to look like a lot like a parallelogram. The main difference is that a rhombus is going to have four congruent sides on top of the fact that it's got these parallel sides here. And that is a very poorly drawn rhombus. Try that again. So a rhombus is very similar to a parallelogram. It has opposite sides that are parallel. But the difference is that it also has four congruent sides. So all those sides are congruent. So because a rhombus is a type of parallelogram, it is going to have both pairs of opposite sides parallel. Technically speaking, you can say that opposite sides are congruent in rhombus, right? Because all four sides are congruent to each other. So that means that opposite sides are technically congruent. It also has four congruent sides. So a rhombus just becomes a little bit more specific type of parallelogram. You will see that like a parallelogram only has two boxes that are checked. Well, with a rhombus, now we're getting to a more specific type of shape. So now we've got three boxes that are checked because it also has those four congruent sides, but it does not have the four right angles. So we're going to leave that one blank. Next up is a rectangle. And so a rectangle, this is like an age-old shape you guys should all know a lot about, has both pairs of opposite sides that are parallel, right? It's got these two long sides that are parallel to each other and these two short sides that are parallel to each other. With a rectangle, we can also say that opposite sides are congruent. So the two long sides are congruent, the two short sides are congruent. But we cannot say that it has four congruent sides because the two are long and the other two are short. But we can say a rectangle is a special type of parallelogram that does have four right angles. So we can see a rectangle meets the same requirements as a parallelogram. That's why it's a type of parallelogram. But then on top of all of that, it also has the 4 right angles. That's what makes it more specific of a type of parallelogram. And then a square. You guys should also all know that a square has 4 right angles. So I'm going to go ahead, I'm going to check that box right away. Square has 4 right angles. A square has 4 congruent sides. So I'm kind of working backwards in my table here. Since all 4 sides are congruent, all opposite sides are congruent, and all opposite sides are also parallel. So it's really easy to see for a square. A square meets all the requirements of a parallelogram. It's got these 2 check marks. It meets all the requirements of a rhombus because it's got this one added on. It meets all the requirements of a rectangle because it has this one added on. So like a square is the most specific one of all of these shapes. A square is a rectangle. A square is a rhombus. A square is a parallelogram. And then last but not least, we also have a trapezoid. So a trapezoid is the whole reason that we have that first column here, exactly 1 pair of opposite sides are parallel. That is true for a rhombus. A rhombus, unlike all of our other shapes, is only going to have 1 set of parallel sides. It does not have opposite sides that are congruent necessarily. It does not have 4 congruent sides, and it does not have 4 right angles. A trapezoid really only meets the exactly 1 pair of opposite sides are parallel. Okay, we are going to jump down and take a look at numbers 10 through 17 now. And one thing I want you to do in the directions here, it says to classify each figure using the name that best describes it. Do me a favor and circle the word best. What I highly recommend that you do is have that diagram with our flow chart on it. And when it says to give the best name that it describes, it means we want to go as far down this flow chart as we possibly can. So like for number 10 here, I know that it has 4 sides. So yeah, it is a quadrilateral because all of these are quadrilaterals if they have 4 sides, but we want to give the most specific name possible. So I can see that it has opposite sides that are parallel. It's a parallelogram. I can see that it's got 4 right angles, so it's a rectangle, but more specifically, the best way to describe number 10 is a square because it's got 4 congruent sides and it has 4 right angles. So we want to go with like the lowest name possible on that flow chart. Now, when we jump to number 12, I know that it's at least a quadrilateral, right? Because it's got those 4 sides. I cannot say that it's a trapezoid because it doesn't have any markings showing the parallel sides. And I also cannot say it's a parallelogram because again, it's got to have parallel sides to be either a trapezoid or a parallelogram. So since this one has no parallel sides, we would simply say that this is a quadrilateral. For number 14, as soon as I see 2 sets of parallel sides, I instantly know that I have to go down the parallelogram side because a trapezoid only has 1 set and a parallelogram has 2. So I know it's at least a parallelogram. In order to be a rhombus, it would have to have 4 congruent sides, which this does not. And in order to be a rectangle, it would have to have right angles, which this does not. So number 14 is a parallelogram. That's as far down the flow chart as we can go. For question number 16, as soon as I see that it has 1 set of parallel sides, I know it's at least a trapezoid because trapezoids have exactly 1 pair of parallel sides. And then for this one in particular, since we have these 2 congruent sides, the word isosceles tells us that we have 2 congruent sides in our trapezoids. This is an isosceles trapezoid. What I would like you guys to do is go ahead and get the video paused right now. Probably have it paused for, 2 or 3 minutes. I want you guys working on 11, 13, and 15, and 17. And then once the class is done, you can press play for me to go over those answers. So for number 11, because we have exactly one pair of parallel sides, it's at least going to be a trapezoid. But we cannot say that it's an isosceles trapezoid because these two opposites or these two other non-parallel sides are not congruent to each other. And so it's just a regular trapezoid. For number 13, as soon as I see that it has two pairs of parallel sides, I know it's a parallelogram. And then I want to decide, could it be a rhombus or a rectangle? It cannot be a rectangle because it doesn't have right angles. It cannot be a square because it does not have right angles. But this one can be a rhombus because a rhombus needs 4 congruent sides, and these are all congruent. So this one is a rhombus. Number 15, you should have looked at that one right away and said that is a rectangle. And for number 17, the only thing that we know for this one is that it has 1, 2, 3, 4 sides. They are not parallel at all. And so this one is a quadrilateral. All right, and then to finish this up, I want to go ahead and take a look at our bottom portion right here. And in this bottom portion, we have to determine whether the statement is always, sometimes, or never true. And so to do these ones, I highly recommend that you use that flow chart that we've been using so far, because to me that flow chart is super duper helpful. So like for number 18, a trapezoid is a rectangle. Trapezoid is over here on the left of my flow chart. Let me go up so you can see that a little bit better. A rectangle is over here. They are on completely different sides of the flow chart. And since they are on completely different sides of the flow chart, these ones are going to be never true. So for number 18, it is never. Let's jump over to question number 19 to the right. And number 19 says a rhombus is a parallelogram. So I want to look at a rhombus and a parallelogram. And the way that this is worded is saying that a rhombus is a parallelogram. Well, a rhombus is a subcategory of a parallelogram. And so this statement here will always be true because a rhombus is always going to be a subcategory of a parallelogram. So go ahead and pause the video for about a minute. I want you guys to try 20 and 21 and then press play for me to go over those answers. So for number 20, it says a square is a rhombus. So I'm going to look at where square is and where rhombus is. A square is a rhombus. A square will always be underneath that subcategory of rhombus, and so this one is always true. And then for number 21, it says a parallelogram is a rectangle. So in my diagram, I can see that this time the word parallelogram comes above the word rectangle. So a parallelogram, yes, it's true. Sometimes a parallelogram is a rectangle. But sometimes a parallelogram is a rhombus. Sometimes it goes in the opposite direction. So this one would be sometimes true. Because a parallelogram can be both a rectangle and a rhombus as subcategories. So we can't say that it's always a rectangle because it will sometimes be a rhombus.